Hi guys, welcome to the 404 assignment Zoom. So in this assignment, I will show you how to get a passing grade on your 404 quiz in the distance learning course page. So if you take really good notes as I go through each question, they will be exactly the same type of questions you will see on the 404 quiz. So let's get started. So for the first question, it said the sides of a square are 4 to the 2/5 inches long. What is the area of the square? So an area of any rectangle or square is length times width. So we need to measure or label that length times width. So we're going to put down what they told us, which is a square, which means it has the same length and width. And there's actually two ways to solve this problem. So you can either multiply the two sides, like length times width would be, but when they match, you could actually go 4 to the 2/5 squared. So it's actually 4 to the 2/5, that it's already 4 is being raised to the 2/5 power, and then the whole answer is being squared. Because if you knew, like for example, that the length was x and the width was x, you could find your answer by doing x times x, which is just x squared. So you can actually solve this problem two ways, and I'm going to show you both ways. So for the first one, that's product of powers property. So what that means is you have to multiply the exponents. If they have the same base, you're going to add them. So if they have the same base, so that they both have a 4 as the base, you would add the two exponents together. And this one's super easy because it already has a common denominator. So you just add across. 2 plus 2 is 4, and keep the denominator of 5, just like you would add a normal fractions. And so this answer would be 4 to the 4/5 power. So now for the second way of solving it, if their two are close to each other, that means you're going to multiply the two exponents. So 2/5 times 2. When you're multiplying two fractions, though, you want to make sure that the second one is also a fraction. So we have a fraction times a whole number, and that 2 can be turned into a fraction by just putting a 1 underneath it. So now we're going to go multiply straight across. So 2 times 2 is 4, and 5 times 1 is 5, giving you the same answer we got as above. So either way, you're going to get 4 to the 4/5 power. All right, so before we go on to the next few slides, I want to make sure you guys understand and we do a little bit of a review for rational and irrational numbers. So we have our Mr. Rational right here, and he's going to tell you there's an acronym to be able to remember what rational numbers are. And that acronym is fractions, integers, terminating decimals, repeated decimals, so FITR. So if you can remember FITR, and if those numbers categorize into any of those sections, then it's a rational number. So fractions are exactly that. They're just fractions. So here are some examples. 1/2, 2/3, 5/6, they're all fractions. Integers are your counting numbers. So that's like 0, 1, 2, 3, 4, and 5. Terminating decimals are exactly that. They mean they end, so they don't go past, a couple decimal points. So you have 1.25 as an example, 4.5 is another example, 101.2, that's another example. So that means they don't go any further. They're not just rambling decimals. And then repeated decimals are exactly that. Like you would abbreviate a repeating decimal by putting a line over the top of it. So for example, 1.33 repeating, 4.9 repeating, or 5.25 repeating. So whenever you have two digits that are repeating, that can also be a repeating decimal. So like 5.25, 25, 25, 25, that's repeating the two 5s, so that's also a rational number. All right, so irrational, IR or ir, is the prefix meaning not. So in other words, that's not rational, which makes sense because it's the opposite of being rational. So all of the non or not values that we have on the other side that make it rational are going to make it irrational if it's not those things. So for example, if we have a perfect square, that would be a rational answer. So a perfect square would be like the square root of 16. Well, that would be 4, and 4 is a rational number. But what about if you can't take a perfect square, like for example for this one, square root of 2. So you can't take the square root of 2, so that's an irrational answer. You can't take the square root of 13, and you can't take the square root of 91. So I want to clarify that this also means that you have to simplify those radicals. So if you have a big radical like 125, you want to make sure that you break it down into the smallest parts that you can break it down into, because that could also make it into a rational number. But if it's just a standing alone radical that has a number that you can't break down into anything simpler, then it would be an irrational number. So now for the next one, you have non-terminating decimals. So that just means that like pi, that's a decimal that never terminates, it never ends, or it fills up your screen on your calculator. So like a decimal just keeps going on and on and on and never stops. But it also means that it has to not repeat. So a repeat, like for example, 1.3 that goes on forever, like from a repeating decimal side, that makes it a rational number because it repeats. But these last two things for non-terminating and non-repeating kind of go hand in hand together. So if it fills your entire screen of your calculator up and there's no repeating patterns of any sort, then that would be an irrational number. So pi are really good examples of that because pi goes on forever and pi also doesn't repeat. All right, so let's go over some relationships. So we have rational relationships. So that's when both numbers are both irrational, both rational. What kind of answers will you get? So if you're adding the two together, if they match, the two rational times plus a rational, you're going to get a rational answer. So the rule for rational is if they're the same, then they're rational. If they're different, then they're irrational. So that's kind of like the general rule, but there's a few exceptions that I'll show you in a second. So for the product, which means you're multiplying, if they're the same, which is a rational number times another rational number, then it's going to be rational. So when they're the same, it's rational. So let's take a look at the next screen. So this is when they're different. So a rational number times an irrational number. So like for example, 2 times the square root of 2. So if it's multiplying, you're always going to have an irrational answer, except if the rational number is 0. So that's the second bullet. But the first bullet, if you're adding a rational plus an irrational, if they're different, it's irrational. So if they're the same, it's rational. If they're different, it's irrational. So the same thing going to go for the bottom one. If they're different, for the product, it's going to be irrational, except for if you use 0. If you use 0 as your rational number, then it's going to make it rational as an answer. So let me give you an example. So if I said 2 times the square root of 2, like I said before, will give us 2 square root of 2. So that's irrational. But instead of using 2, if I use 0, 0 times anything gives me an answer of 0. And we know automatically 0 is a rational number. So that immediately makes it false for this bullet. So you can't use 0 if you're multiplying because 0 immediately defaults to a rational answer. All right, let's go on to the next slide. So now we're talking about when they're both irrational. So this is where it gets a little confusing, and I apologize for this, but just remember, irrational doesn't make sense. Just like if you're trying to talk to somebody that's irrational, they don't make any sense. They're talking, in circles, and it just doesn't make any sense at all. So irrational is exactly that. It just doesn't make sense sometimes. So that's another thing you can remember. So if it's irrational plus another irrational number, it's going to be sometimes. And if it's irrational times an irrational number, it's going to be sometimes. And the reason why is because sometimes two irrational numbers, whether they're adding or multiplying, could equal a rational answer, just depending on the combination of those two irrational numbers. Not always, but sometimes it could make a rational answer. For example, if you take the square root of 2, which is irrational, times the square root of 2, which is also irrational, your answer is actually 2, which is rational. So the rule with, being both the same, it should be rational. Technically it's true in this situation, but for irrational and irrational, it should have been irrational. So just know that it's sometimes. So if you see two irrational answers for any relationship, your answer should down below be sometimes, unless they ask you for the false, like which one's not true. If it asks you for which one's not true, make sure you read the question carefully. All right, so talking again, if it's rational and irrational, it's always rational. If it's multiplying rational and rational, then it's always rational. If it's adding and they're different, then it's going to be always irrational. Remember, if they're different, it's irrational. But if they're adding and it's the same, then it's sometimes irrational, because remember, when they're the same, sometimes, same for sometimes, when it's only irrational. Irrational is that really weird rule, remember. And then the product, if it's doesn't match, so if it's rational and irrational, then usually it's irrational, but if it's a 0, then it wouldn't work. So as long as any other number other than 0 for the rational, then it will always be irrational. But if you use 0, it's immediately irrational. And then the last one, the product of an irrational number for an irrational number is sometimes irrational. And again, if they are the same, sometimes it'll be irrational. That's just because the irrational rule is irrational in itself. All right, so now moving on to the second part of this quiz, it's asking you to find the compound interest rate for word problems. So we have Jessica puts an initial $800 into a savings account. The account has a 3% annual compound interest rate. What is the function that best represents Jessica's account? And how much does she save after 6 years? Round your answer to the nearest dollar. All right, so we have $800, which is the principal, so that's the capital P. We have the interest rate, which is 3%, and we can't use 3%. We have to change it to a decimal. So you have to make that 3% as a decimal. And then we also have the X value. X value stands for time, and they say that we have to find it after 6 years. All right, so we have 800 we're plugging in for capital P. Then we copy down the 1 plus. And for R, we have to convert that 3% to a decimal. So right now that decimal is on the right-hand side, but if you want to make it a decimal, you have to move it over 2 places to the left or divide it by 100. So if you move it over 2 places to the left, you get 0.03. Hold on a second, I have somebody keep messaging me. Okay, so 0.03 is what we're going to use. And then you're going to raise it to the X power. And in this slide, I actually raise it to the 6th power, but your function, before you put any number into it, is actually raised to the 6th power, or to the X power. So that orange 6 should actually be an X for your answer for this problem. And then your final answer will be how much is in the savings account after 6 years. So now you're going to calculate it, saying how much will be in her account after 6 years. So you're going to add what's inside the parentheses first. So when you add 1 plus 0.03, you get 1.03. And remember, with order of operations, we have to do it in order of parentheses first, then exponents, and then your multiplication, division, and then addition, subtraction. And I write MD next to each other because it's whatever comes first. If division comes first from left to right, that's what you should do first. If multiplication comes first, left to right, that's what you should do first. And same goes for addition and subtraction. But for this problem, we only have an exponent and then we have a multiplication left to do. So we're going to do our exponent first. So that's 1.03 to the 6th power, which gives us a very long answer. And then you're going to leave that in your calculator and don't round it. So don't round it to 1.19 and use that number, because that is rounding in the middle, and you never want to do that in the middle because you'll end up with the wrong answer in the end. So keep it in your calculator and then multiply it by 800. And if you look up above, it says round your answer to the nearest dollar. So if we had originally $800 in our savings account, so that's how much was in the savings account before we even started. And then we waited 6 years, and in that 6 years you were earning $4.16, so $4.16 if we were to round it to the nearest penny. So that's $804.16. But the problem says to round it to the nearest dollar. So that 16 cents isn't big enough to go to $805. So we're going to say approximately $804 she will have in her account after 6 years. And you're probably wondering, wow, that is not very much money. She only earned $4 in 6 years, and it was, $800. $800 is a lot of money. Well, 3% isn't very high interest rate. So in order to earn a lot of money on a 3% savings account, you have to have a lot of money in there to start. All right, so the next problem says an animal sanctuary covers an area of 2,500 square kilometers. Suppose each year this area decreases by 5%. What is the function that best represents the area of the animal sanctuary each year, and how much area remains after 10 years? Round your answer to the nearest square kilometer. Hint, use the formula f of x equals capital P times 1 plus r to the x power. So actually, this isn't correct because it says decreases by 5%. So you should actually use the formula capital P times 1 minus r to the x power. Because remember, if it's decreasing, it's taking away from the original amount. So every year, it's taking away 5% from that 2,500 square kilometers. So what you're going to do is you're going to identify the values that we have. So our principal amount, like we did on the other side, was 2,500. And then we have 1 minus r instead. So I wrote decay, so we're going to change that to 1 minus r. And that 5% you have to convert to a decimal. So like I did before, we're going to move our decimal place 2 to the left, making it 0.05. Another way to remember it is if you had 5 cents, then how would you write that as dollars? And that would be 0.05. You would write as if you had 5 pennies. So now I'm going to just move that over and put that back up with an x there. So that is our function that represents the situation. F of x equals 2,500 times 1 minus 0.05 to the x power. So now it wants us to find out how many it would be to the 10 years. So how much would be left after 10 years? So f of x goes in the front. So now I'm going to combine that parentheses, and you have 1 minus 0.05 is 0.95. And that makes sense because if you started out with 100% of those kilometers, so you had 2,500 to begin with, after a year, you're going to be left with only 95% because every 5% that is going away. So it's decreasing by 5% each year. So if you're taking away 5%, you have to take it away from 100. So 1 minus 0.05 is 95%, or 0.95. So now you're going to substitute that x with a 10. And remember, you have to calculate your exponent before you multiply by 2,500. So when you calculate the exponent, you're going to get a very long decimal. And we're going to bring down the 2,500. So now that you've calculated your exponent, the next thing in the order of operations is multiplying. So we're just going to multiply those two together. And you get 896 point blah, 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 which is a lot of decimal. Blah, blah, blah means lots of decimals. So then we look back up in the problem and it says to the nearest square kilometer. So we are going to, first you have to start out with how much you had originally. So to the nearest square kilometer, that would be 896 if this was to be rounded. So 896 is what this would round to, because 0.214 is not big enough to make it go to 897. But we started out with 2,500 kilometers in the beginning, right? So if we're going to subtract 896, then we need to find out, after we subtract 896, how much do we have left? So what that means is after 10 years of every year taking away 5%, after 10 years, you are left with 896 square kilometers. So you don't have to subtract it from the original amount to start with, because this is already calculating after 10 years taking 5% away each year. So you would only be left with 896 kilometers, so square kilometers, and that's how you write square kilometers. All right, for this last one, it says, given the function h of x equals 3 times 4 to the x power, find these two sections when they equal certain x values. So we have x equals 1 to x equals 2. That's for section A. And for section B, we have x equals 3 to x equals 4. So you're going to have two answers for part A, and then for part B, it says how many times greater is section B than section A, and why do you think that's so? So you have two answers for for part B as well. So first thing we have to do is you have to use the formula, which is the slope formula, y2 minus y1 over x2 minus x1. So your y2 and your y1 are your answers after you plug in the x2 and x1 into your original function. So first, to find which x2 and which is x1 is whatever x values that they tell you first. So that x equals 1 is your x1, and the x equals 2 is your x2 for section A. So we're going to plug those in and find what our y1 and y2 answers are. So for the first one, I just wrote our denominator. We already know what x2 and x1 equals, so I just put 2 minus 1 on the bottom. and that just comes from what they gave us. And now I know I'm going to plug in for x2. I'm going to plug in 2 because I'm trying to find the y2 answer. x2 and y2 go together, and x1 and y1 go together. So when I go and plug 2 in, when you're writing h of x, you don't need to write h of x anymore because you're plugging 2 in, so you actually write the number that you're plugging in inside the parentheses. So if we're plugging in 2, we put 2 in the parentheses. And then we're going to calculate our exponent first and then multiply it by 3. So 4 squared is 16, and 16 times 3 is 48. So now I'm going to plug in 1 to find our y1 answer. So I write h of 1 time equals 3 times 4 to the first power. 4 to the first power is 4, and 4 times 3 is 12. So now I have 12 that I can plug in for my y1 answer. So now I have my entire formula filled in, so all I got to do is subtract and then divide, and I have my answer. So 48 minus 12 is 36, and 2 minus 1 is 1, so 36 over 1 just equals 36. So that's my answer for section A. And on this problem, this is similar to the question 4 on your quiz. You have to show all of your work for question 4 or you won't receive full credit. So all of the algebra teachers that are grading, if they don't see full your work, you're not going to get 10 out of 10 for this question. So make sure you show all your work, and this would be showing all your work for section A. And you're going to do the same thing for section B. I'm erasing it on the screen because I ran out of room, but you should not be erasing anything when you put it into the additional comment box. So if you need to write an exponent, remember you use the symbol that's above the 6. It looks like an upside down V. So if you wanted to write x squared, you would write x and then hit that symbol and then a 2. So make sure you use that symbol to represent exponents. All right, so now we're going to do section B. So same thing, section B, but now we're using x equals 3 and x equals 4. So that's my x2, and I put that there. That's my x1, because that's the first x value they gave me for section B, and that's the second x value they gave me for section B. So I put 4 minus 3 down below, and then on the top I'm going to plug in 4, then I'm going to plug in 3, and put those two answers for y2 and y1. So if I plug in 4, I put 4 in the parentheses, and then my exponent is going to change to a 4 because that's what I'm plugging into the equation. The only thing you can plug into is if it has an x value, and my x value is right here. So that's the only thing in our actual function that we can plug into. So we have 4 to the 4th power, which is 256. 256 times 3 is 768. So that's my answer for when x equals 4. And then I'm going to do the same thing for when x equals 3. 4 to the 3rd power is 64. 64 times 3 is 192. So now I have my entire formula filled out. I just subtract and divide and I'm done. So 768 minus 192 is 576. And 4 minus 3 is 1. So that just simplifies to 576. So that my section A answer is 36 and my section B answer is 576. So that's all it asks you to do for part A. And you should be showing your work for all of that in your answer for additional comments. So now for part B, it asks us how many times greater is part B than part A. So if you think about this in a real world situation, if you have $25 and your brother has $5, how much times more money do you have than your brother? So if he has 5 and you have 25, you have 5 times more money than he does, right? Well, how did you do that? You just took 25 and you divided it by 5. So that's all we're going to do here. We're just going to divide our section B by our section A answer. So that's 576 divided by 36. And in your answer for question 4, if you do not get a whole number, you did it wrong. All of the answers for these questions, and there's about 10 different questions that you could possibly get, they all are whole number answers for part B. So the times greater needs to have a whole number. If it's a decimal, you did something wrong in part A. So now the second part of part B says explain why one rate of change is greater than the other. So that means you need to look back up and see, well, why did I get a bigger answer for section B than I got for section A? And that's pretty clear. It's because they had higher exponents. So the higher exponents that you're plugging into the equations, the higher answers you're going to get. So because section B had higher range of exponents, it gave a higher answer, and that's why we got a higher answer for section B. All right, so that's all there is for 404. So go ahead and take your notes that you took on this video and go and complete your section 404 assignment on the distance learning course page. Good luck.